In this video you'll learn how to create this lightning effect for your 2D game. Hey, so I decided to go with a slightly different video format. Basically, instead of typing all the lines in the scripts, I will copy and paste them from my other screen to the one that you're seeing, just to keep the format more compact and also to avoid all the typing mistakes that I make during video and such. But you will still see how I set up each scene, so you get overall workflow and why scripts are set up in such a way. Okay, so let's jump into the video. Let's create 2D scene. Let's rename it to lightning. And also let's change the type to line 2D. And let's add animation player. Cool. And now let's save the scene and let's add the script. And let me copy it. Okay, so now first line we're getting the reference to the animation player. Then we got a bunch of variables, divider, points lerp, which we will use to store offset of position. Basically we'll use the float between 0 and 1, so for example 0.1, and then we'll use it to offset the points along the path. We got sway divider, which is of 40. Then we got two functions, set start, which accept at position vector 2. This will set up the first point in the path. Then we got set end, which also at position. This will set up the last point in the path. After that, we got two functions. One is segmentize, which accepts from 2, which is vector 2, then start position, which is vector 2 as well, and returns void. Then we clearing the lerp. So just in case if there are any points in the points lerp array, we clearing them. Then we grabbing the distance, so we're getting from 2, which we passed, and we're grabbing the length of it. Then we're getting the sway, so we're getting distance by sway divider. So this will allow us that if basically it will take the length of the whole lightning divided by sway, and this will give us the strength of the lightning, how much it will jiggle around. After that, we're also clamping it to 10, so if we have very long lightning, it won't go all over the place. After that, we grabbing this segment count, which is distance by divider. So this allows us, and basically the longer the lightning is, the more points we will have that we can offset along the path. Alright, after that we're getting the point in range of segment count. So it will loop through each point and create a new value between 0 and 1, which is float, and append it to our points lerp. After that, we are sorting the points lerp, so each value goes from lowest to highest, and then we're doing point index equals 1. After that, we're looping through points lerp. So we do at point, start position plus point offset plus times from 2 at point index, and then point index plus equals 1. So how it works, it takes the start position of that we passed, then it adds point offset from points lerp, so for example value 0.1, then it multiplies it by the whole length of the lightning, and it sets the point based on the point index. So for example, if you have the points lerp array and you have value 0.1, so that point will be at 10% of the whole length of the lightning. And then after that we got function sway, which will offset our points on the like in the direction of the lightning. And we're passing the normal through it, which is vector2, and returns void. So we do var point count, and we're getting all the points that are already created from segmentize -1. And after that, we do for point in point count. If point equals 0 or point equals point count, continue. So this will skip our loop if point index is 0 or point index is the last point in our line. And then basically it will skip it. And else we calculate the offset. So we could do get point position point plus get point position point -1 divided by 2. So what this does is it takes the point we currently iterating over, then it takes the point behind it in the line, so on index -1, and it creates a position between each of them, so dead in the middle. After that, we're adding normal to it, and then we random range sway. So it will take the normal, which is if you have the direction, for example, on x-axis it will be 1, then your normal will be on y-axis. So it will then basically offset each point by a random amount on minus or x or positive axis of y, and then set point position, and we're passing the index of the point and also the offset that we calculated. After that, let's create our generator that will create our lightnings. So we will create new scene, 2D scene. Let's rename it to lightning generator. Okay, let's save it and let's add the script to it, and let me copy it. Okay. No, that's the wrong script. Why you didn't copy it correctly? Now, there it is. Okay. So we're creating new signal, flash. We will use that signal to flash the screen white when the lightning is instanced. I won't be showing this in this video, just in case someone sensitive to flashing images is watching this. So you are safe to watch. I commented the lines that control it, so you are safe to watch. Okay, then we export variable Subforkify bool false. This allows us to, for example, set it in the inspector if we want subforks. So for example, lightnings that go off the main lightning. Okay, so let's go back to the screen script. Then we got var lightning scene, packed scene, preload lightning scene. So we basically loading the lightning scene that we will instance. Then we have for count, which will control how many core forks we want in the lightning. So for example, the forks that go from the initial point, so lightning generator, towards the mouse position. Then subfork count, let's keep it at 0. Okay, subfork count will account for how many subforks we want, but we will generate them dynamically based on the length of the lightning. Okay, then we got forks array. This will store our core forks. Then we got subfor length, which will be controlling the length of our subforks. After that, we're storing mouse position. We're storing from to, which is basically direction vector. We're storing the normal, which will be, as I explained in just a moment ago. Then it will be fork offset, which will control how much from the central lightning that goes directly to the mouse position, we want other forks to go away from it. Then we got target, which we'll use to define where the point should go. And then we got length offset, which is 1. Okay, now in process function, we got if input is action mouse pressed. So I just set it up here. So you can see it's just mouse position, mouse button. So if we click the mouse button, we want to grab the mouse position in the screen. After that, we want to clear the forks array, and then we're looping through how many forks we want. So basically it will loop, like if we define 1, it will just create 1 fork. If it will be 3, it will create 3 forks. After that, it's var lightning instance. So we instancing the scene that we have pre-packed. Then if fork equals 0, target mouse position. So if it's first fork that we're creating, so the core fork, as I like to call it, we defining the target as mouse position. But if it's different forks, so subsequential created, we want to create length offset random f. So this will allow us to have shorter forks on the sides instead of all of them going the same length. After that, we're doing target equals mouse position plus normal run range fork offset length offset. So this will offset, basically it will take the mouse position, then takes the normal, so we rotating the vector that was pointing towards mouse position by 90 degrees and offsetting it, so it will create this fun effect of the lightning. And we creating light off, and we multiplying by light offset, so it will shorten it or keep it at the same distance, because it's random float from 0 to 1, so it can be either 0, any value between 1. Okay, then we setting our from to, which is target minus global position. So this gives us direction vector towards the target. And then if Subforkify, so if our variable is set to true, we're doing subforkCount from to length divided by 40. So this will create, basically we'll take the length of the core of the lightning, then divided by 40 and create how many subforks we want. So it will basically, you can change this parameter to anything, and it will basically, you will have less or more, like the lower the value, the more subforks you will have. After that, subfork length, it's the same, fork from to length divided by 5. So we're taking the whole length of the lightning divided by 5, which will give us basically all the subforks will be shorter than the core of the lightning. If we do this, we'll remove it, it will be the same length as the core. So let's keep it at 5. Okay, then we're calculating the normal, which is vector 2 from to y minus from to x, and then we normalize it because we want value from 0 to 1. So this will allow us to get the vector rotated by 90 degrees. After that, we adding the child as lightning instance, and then we referencing the lightning instance and calling set start at the global position, because we instancing the cores, the lightning core. After that, we setting the end position for the target. We setting lightning instance segmentize from to global position. After that, lightning instance sway normal. So we're passing the normal to the sway function in the lightning instance. After that, we're waiting 1 frame and we're playing the animation player fade. I will comment it for now just to show you, because otherwise it will throw me an error and I want to show you how it looks like. After that, it will be forks array, append, lightning instance. So we storing this lightning instance that was just created in the forks array, so we can reference it for the subforks. So if subfork counts is more than 0, we want to create them. So for subfork subfork in range 0 subfork count. So if it's like 4, it will create 4 subforks. We picking one of them, of the core forks that were created. So picked fork, line 2D, forks array, we convert it to int, random range 0, forks array size -1. So if we have a 1, well, it will be easy, it will be 1. But if it will be like, for example, 3, it will pick random fork and add to it. Okay, then Subforkify, we call this function, which is over here, and we passing in normal and also picked fork, get point position, rand range 0, picked fork, get point count -1. So what we're doing, we picking the random point inside the core lightning. So for example, it can be at index 1 or index 10 or whatever index there is. After that, we waiting 1 frame, we emitting the signal flash, then we waiting another frame and emitting another flash. I will show you soon the script that controls the flashing of the screen. Of course, I won't show it in the video. Then we create function Subforkify, which accepts normal, which is vector 2, and also the point vector 2, so this point from here. And then it returns void. Then we create a new lightning instance, so line 2D, lightning scene instance. We do var subtarget vector 2, and then we do point. So we grab the point that was passed. We adding the normal from the whole, the core of the lightning. We multiply it by rand range, so subfork length, so the variable we defined here. Then we adding it to it target divided by 4 times random float. So this will move the fork towards the same direction that the core lightning is pointing, because otherwise they will be just 90 degrees off. But with that, they will slightly rotate to face the same direction as the core lightning is going. Okay, then we got the new variable sub from 2, so basically subtarget minus point. So this is where the sublightning will start, and this is where it will end. Then we got subnormal, because we needed to define offset or sway for each point in subforks. So we got sub from to y minus sub from to x normalized, which will give us the rotated by 90 degree vector. Then we adding the child of lightning instance. Then we got lightning instance set start point. Set start at point. So the first point will be where the point is in the core of the lightning. And then we doing lightning instance set end subtarget. So we defining the last point, which will be where the lightning should go. After that, we got lightning instance segmentize sub from to point. So we basically passing the our direction vector and also the point where the lightning should spawn. And after that, we're doing lightning instance sway subnormal. So we're passing this normal here. Okay, then we're waiting one frame, and same, we're doing the lightning instance play animation. Okay, and now if I play the lightning generator scene, you can see it creates the lightning. It's jagged and all that, but obviously it doesn't delete itself yet. And also if I accept this Subforkify, you can see the lightning gets like all the subforks created and jagged. Now let's create our base scene. So new scene, 2D scene, let's call it base. Let's add to it camera, 2D. Let's set it to current. Let's add to it control. Let's add to this color rect. Also to the base we will add world environment, and we will link our lightning generator. Okay, so here in the control, let's rename it to flash, and in rect we want to set min size to larger than our camera bounding box. So let's set, for me, I'm on the default resolution, so it's 1024 by 600. So I will set it to 1040 on x-axis and 620 on the y-axis. And then I will move it with snapping to the center, so it envelops the whole screen. And color rect, we want to layout full rect. So this will flash our screen, and I will just hide it. And let's save the scene. In world environment, we want to go environment, new environment, open it. In background, we want to set canvas. After that, we want to go glow, enabled, and let's set it to 1, 1.5, 1.2, and save it. Now we'll create also the base scene screen script. So let me just copy it quickly. Nope. Here you go. So we got onReady flash, which will grab the reference to the flash. Then we got onReady lightning generator, so we're grabbing the lightning generator here. And then in function ready, we're calling randomize, so it will randomize the seed of the generator and basic random number generator. So every time we run the game, it will be different results every time we randomize. Okay, then in lightning generator, connect flash self on flash, and here we got on flash void, and we accessing the flash node. Here we taking the visible equals not flash visible, so this will return opposite of what it is current. So if it's true, it will return false. If it's false, it will return true. Okay, and now that's basically the setup, but let's juice up our lightning. So we will go into our lightning scene, and we'll get the animation player, and we'll create new animation called fade. I will set it to 0.5 on the time, and then let's zoom in. Let's add track, not add track, let's do lightning. Let's set first of all width to 3. Let's do fill. Let's do a new gradient. Okay, and now we want those two variables as a keys. So I will create new key for the offsets, new key for the color, and let's move it back. Let's add it as well on the end. And now here in the first key of the offset, we don't want to change anything. It should be 0, 1. In second one, what we want to do is set first point to 1. So if you look at the gradient, basically this point will be all the way here. Okay, now here in the color, what we want to do, we want to set 0 to white, and in the second key we want to set 0. Let's set it to like nice light teal color, and also set alpha to 0. Okay, and now if we do continuous blending, so it doesn't jump suddenly but instead blends, and we run our base scene, you can see, okay, I forgot, we commented the lines that control the animation. So let's do fade and fade. Okay, and now let's also disable the Subforkify, and not this scene, and let's run it. You can see it fades, but it doesn't get deleted, and also we got this leftover thing. So what we will do is, in the lightning, in animation player, what we want to do is here, add track, call method track, we want lightning, okay, insert key, and we want Q3. So this will delete our lightning as soon as it reaches this point, okay, in animation. And now if we run base scene again, you can see it completely, I clicked off screen, it's deleting our lightning completely. Okay, and then also what we want to do in lightning, let's add width curve, new curve, and let's edit it. Let's set it to 0, 3, so in the range, min value 0, max value 3, and let's add a few points to it. It doesn't matter how many, I'm just adding randomly. And then let's offset it in some way. Let's do like this, like this wave pattern, and let's save. And in base, if you play it, you can see the width of the lightning changes as it goes. So this creates this illusion that the lightning doesn't go only on a flat surface, but also goes away and into the camera, which is quite a nice effect. Okay, the last thing we want to do to finally like polish the our lightning effect is add this flicker. You know how the lightning goes through the sky or through the clouds, it flickers. We want to simulate the same effect, but we can't use the gradient because we're already using it. So what we will use is, if we scroll down in visibility, we have modulate property. So we will add the key at the start, and then we will set the snap to not 0.5 but 0.5. And this allows us to have more control and more keyframes on the timeline. And then we will just insert them randomly. Let's say here as well, and here. And then what we will do, we will change the update mode to discrete. So it will snap to each point in the color. And then we will change the color of them to be darker. Here also even more dark. Oh no. Here let's do slightly lighter. Here let's do darker actually. Here let's do slightly darker and lighter again. And now if we run the scene, you can see it flickers, it fades away nicely. And also in line, what we want to do is, in cappings, we want to round, round, and round. This will give us the joint modes. The lightning on the joints will be rounded, and also the caps at the end and the beginning will also be rounded. So if we run the scene again, it will give us much smoother effect. Okay, and that's basically it. That's how you create the 2D lightning that forks, that fades away as well. So yeah, thank you for watching.